see about our amplifier stabilization. So stabilization is nothing but throughout the transmission we have to maintain our stability of amplifier. Suppose if you are having some power dB in our source placements, but power dB also available in our destination also. Okay, so that is called as a stability criteria. So stability maintenance depending on our S parameters. So first output stability circle, then another one is the input stability circle. So if you are maintaining input stability circle means that is also maintained in our output stability circle. So we know that communication class of this is our amplifier. So this is our source. So this is our load or destination. So both are same. So the source stability and load stability should be maintained the same level. Then amplifier should be matched in your source and also destination. That is nothing but our load. So this is called as matching network. So similarly, this is also matching network. So input matching network, then output matching network to the load and then to the source. So this amplifier should maintain the overall the stability of our entire transmission. That is called as stability circle. So first we are going to see about output stability circle. So output stability circle. So this is our output stability circle. So for load. So this load is taken as x-axis is reflection coefficient at load. Then similarly y-axis is reflection coefficient load. Okay. So this is gamma is nothing but reflection coefficient. So this is our resistance. This is our current. So both will be maintaining at load only because we are seeing about output stability. So that's why we are focused on only load side. So that's why this is and then this portion also mentioned in the reflection coefficient at the load. Okay. So this is an entire circle of 4 quadrangle. So in this 4 quadrangle we are represented in this output side, that is load side. So this 2 quadrangle we are mentioned in the load side. Okay, ma'am. So this load side, so output circle also mapped with your small circle. So the small circle, the margin in the radius. So radius output side. Then similarly C out. C out is nothing but capacitor or so control output. So both are same. So this circle is a reference circle. So this circle will be maintained by the also referenced by the scattering parameters, that is reflection coefficient scattering parameters. The same port, why we are mentioning same port means that S11, the single port. For example, 2-port network means this is port 1, this is port 2. So reflection coefficient at 1 means, so we are mentioning S11. So this is reflection coefficient at port 1. So this reflection coefficient at port 1, suppose modulus of reflection coefficient less than 1 means we are representing this circle. Then a reflection coefficient greater than 1 means we are representing this same circle. So only difference between these two are, so this is the less than 1 means this portion only stability. This portion only stability of our amplifier. Suppose this our reflection coefficient at port 11, S11 modulus of greater than 1 means only stability of our amplifier this smaller portion. So these are the main two difference at output side. Okay, output stability circle. So this is stable, this is unstable. So that is also, this is major circle is unstable, then smaller circle is that is stable circle. Okay, ma'am. So this is the same methodology followed in our input stability circle. So input stability circle, the reference circle is like this. So this 2 quadrangle we are referred or we are taken as for representing our input stability circle. So this is major circle, this is smaller circle. So then this place we are mentioning seeing. Then this is radius of input side. So only our x-axis and y-axis representing source reflection coefficient. Similarly, source reflection coefficient resistance and the current. So sources we are taken as in this portion. So this is our source reflection coefficient because we are now concentrated on input stability circle. That's why we are focused on only source. So that's why we are representing source reflection coefficient gamma s. So first we have to representing or we have to draw the main stability circle at the input side. So main stability circle, first you have to draw the major circle, then another one is draw the smaller circle which is mapped to the main circle. Okay. So these two portions are referred as input side because of we are focusing now source side. So this is a smaller circle. So now we are considering at port 2, S22. So S22 is nothing but port 2 reflection coefficient. First we have focused on S11 for output stability circle. Then this is input stability circle. We are focused only port 2, that is S22. So S22, modulus of S22 less than 1 means we have to draw this circle. Suppose another condition, modulus of S22 is greater than 1 means we have to draw this similar circle. Okay. So less than 1 means our major circle is stability, stable of our amplifier. Suppose greater than 1 means only smallest circle will be this portion only will be amplifier stable. So stable of the amplifier, only smaller circle because our S22 greater than 1 means. Okay, so this is a major role played in this less than 1 because of we are choosing this S22 less than 1 because our amplifier stable condition major portion is occupied. So this condition we have preferred. Similarly, in output side, this condition also preferred. Because of these two conditions for both input and output, we have to choose. Okay, ma'am. Is it clear?
Yes, sir.
Okay, thank you.